Okay, this is lesson 3, and this deals with resistors in series and parallel. This one is mostly measuring, so it's more of a lab type. The others sort of have been, but you usually had to do something else in addition to just making measurements. So on this one, we're going to start. Make sure you have all of your resistors and things that it says that you need. And it says to record the color codes of each resistor, and then you're going to determine the resistance based on the color code. Then the third line is to actually measure the resistors. Now, I have 3 resistors that I'm going to use, but they're not the ones that you will be using. So any of the numbers that I get for current or voltage, they won't be ones that you should end up with. Now, in each of these parts, it will tell you to draw the circuit. Sometimes it's easier to draw the circuit first and then construct it. Sometimes, for some people, it's easier to construct the circuit and then draw it. So I'm going to draw the circuit first, and there are a few things to kind of note. When we draw this, we need a power supply. The symbol for a power supply is alternating long and short lines. I usually have 2 sets because I don't really want to do a lot of them. And there is a symbol that's 2 lines that are the same length that we'll use later, so that we don't confuse that. I usually just draw 2 sets. And then we need to draw 2 resistors. It says we're going to have 2 resistors in series with the power supply. Series, of course, means one after the other. When we draw these, if you look at any circuits in a book, they always have square corners. When you're doing this on the circuit board, you very seldom will ever have square corners, but we just draw them that way. So we're going to go up here, and then a resistor is represented by I call it a squiggly line. So we're going to have one of them, and then we're going to have another one, and then we come back to the other side of the power supply. At the moment, it's not really necessary that you know this, but the long side is generally considered the positive side. The short side is the negative side. And then we have 2 resistors in series. It really doesn't matter which one you call R1 and R2. But to be consistent with reading left to right, I'm going to call this one R1 and this one R2. Now, it told you to select the resistors or to label them. The largest one is R1, the next largest is R2, and the next largest is R3. It's not absolutely essential that you do that, but it just kind of makes things, some of the currents and voltages turn out a little bit better if you have it that way. So what we're going to do now is to look at connecting these things on the circuit board. I think I'm also going to draw on the board here a little bit more of the circuit board so that you can make sure that you get things in the right place. Now, what I'm going to do is draw several horizontal lines. These represent the rows on the circuit board. So we're going to have a resistor. I'm going to put a little dot there and draw down maybe to there, and then this is going to be the picture for that resistor. So when I do this, I'm going to put it in a hole on this row and then a hole on this row. It doesn't matter which row it is, I just drew it that way. Then to have series, we need the other resistor to connect to this end of this one. So it has to go in the same row, and then I'm just going to go down to maybe here and then draw my resistor here. Show you that in. And again, it doesn't matter which end you have in which place. Now, we need to connect this to our power supply. So what we've been doing is we had our positive 15 volts here. So we have that knob. It needs to come to this end of this resistor. So I'm going to show it in this hole. And we go up, kind of up here and like that. Then our other one goes from down here, and we're going to put it into the ground, GND. So this is going to come over here and go up to the ground. So that's what our two resistors in series is going to look like. Now, I think we'll go ahead and connect those and kind of see what we have. I still have the red wire and the black wire from the ground and the positive 15 volts. So I'm going to put this one up here somewhere. And then I have my largest resistor. And the values that I have don't really matter, but they're not the same as what you have. So I'm going to put this one in the same hole, in the same row, and then just down here, put it in another hole, doesn't matter where exactly. And I actually have these lined up, but that's not necessary, that doesn't have anything to do with anything. So I have from my positive 15 volts over to where my one resistor is, and then I need to connect into the same row as that. So I'll do that one in the same row, and then put it down here somewhere. Doesn't matter where. So we'll put that. And then I need the ground wire, the negative wire, to go in the same row as that resistor. So we have our two resistors in series. These are all like kilo ohms, so it doesn't really matter exactly where we have the voltage knob, but normally it's best if we turn it down fully counterclockwise before we turn on the power to it. Now, so I think I'll go ahead and turn this on. And then we need to adjust the voltage. Let's see, it says to adjust the voltage of the power supply to 8 volts. So we have our orange meter, and we'll turn it on. I'll push. There we are. And we want it to be connected across the whole thing, the power supply. We could just go ahead and connect it in here, and actually I might show you how to do that. You can open the jaws of the alligator clip and just put it in that hole, and it will connect there, and then we can connect there. And we want to adjust that to 8 volts, so we'll go ahead and turn this up to 8 volts, about somewhere along in there. Okay. Then it says to measure the voltage across each of the resistors. So what we're going to do is take these out of here, and then whichever resistor you called R1, I think I had it as this one, we'll just connect across here, and we'll get a voltage, so you would record that. And then we want to cross the other resistor, so we'll go down here and do that one, and you would record that. Now, it's possible that you may end up connecting the opposite direction, and you might end up with a negative voltage. If you end up with a negative, either ignore the negative, or if you don't really like ignoring it, then go ahead and switch the leads here so that you actually get a positive. Because on all of this, particularly in this lab, you do not record negative voltages. Everything should be positive. So that's how you do the voltages. And then the next thing to do is to determine the currents at several places. So I might go back to my picture up here, and you'll be doing this 2 or 3 times during the lab. It will tell you to measure the current at several points. So this one, it tells you to measure the current between the power supply and R1. It says to label, put a dot and label it. So this would be P1. Then between R1 and R2, so we put a dot and label that P2. Make sure you don't get mixed up with the P's and the R's. And then over here, would be P3, 0.3, somewhere between the resistor and the power supply. Now, when you're measuring the currents, obviously you don't want to cut the wire in half and insert the ammeter there. So if you want the current at a particular point, you go to either end of that wire. So I would say, let's go back over here to P1. If we want to measure the current here, I would go to where this wire is connected to R1. And then we have to break the circuit. So over here, now we need to make sure that our meter, we're still going to use the yellow meter to measure current, and I think it probably tells you there 2 milliamps. I have it set on the 2 milliamp scale. So we need to break the circuit. Anytime you measure current, you have to break the circuit. So we're going to break the circuit. I'm going to remove this wire from the circuit board. So I'm actually removing this wire here, so it's just sort of out here in the air. Then we're going to connect our meter, and if we end up with a negative number, which I think we will, I ended up with a negative number. I really don't like a negative, so I'm going to switch this back to where this is. Okay, so now we have a positive number, so you would record that, and then when you have made that measurement and recorded it, you need to remove the meter and reconnect so that your circuit is back together again. Okay, then if we want between the two resistors, we can undo either one of them. I'm going to pull this one out, and then I'm going to connect from this resistor to this resistor. So we'll get a number. And I don't know if you were watching the other number, but it was about 0.119, just like this one is. So that might give you a hint as to what you should end up with when you're doing yours. Okay, then we take this out, connect the circuit back. So you have to make sure that you take the meter out and reconnect whatever you disconnected. So then over here, we want between the power supply and this resistor, so I'm going to pull this side of the resistor out, sort of have it, make sure the other end doesn't come out, sort of sticking out here in the air. And then I'm going to connect here, and then I need to connect down here. I've got to make sure that I connect where the wire is and that it's not touching other things. So again, we get 0.119. And like I said, that should give you a hint as to what you should end up when you're doing this. So I have removed the meter and I reconnect my circuit. Okay? So then the next part is to add a third resistor in series. So we will have the same sort of picture, except we'll have 3 resistors across here. So I will show you here the easiest way is to remove this ground wire and then insert our other resistor. So if I were doing this, let me show you on here. I would remove this and have my rows here, connect here down to somewhere here. That's where my third resistor is. And then this wire needs to connect in the same row as this one. And it doesn't matter whether it's on the right side or the left side, and the same thing up here. As long as it's in that same row, then you're okay. So I would put this in here and then just bend it and put it down here a little bit farther somewhere. And then have to make sure that this wire is long enough, and then put that in there. So now then I have my 3 resistors in series, and it asks you some questions about finding the current or measuring the current at some point. Okay, so that's what you would have for resistors in series. Now the next part is resistors in parallel. It does say disassemble the circuit, so that's probably the best thing. We'll just pull out all 3 resistors, and I may just leave those wires there, and we'll see if we need to move some of those. Okay, so now we need resistors in parallel. I think I will leave this here, and I will draw some of the parallel things over here. Okay? So we need to connect two resistors in parallel with the power supply. So we draw our power supply first, and I think I will do it in a different color. Maybe we'll try blue, so it's easy to tell the difference. So we have a power supply, and then we have one resistor, and so this is R1. Now, the reason it's called parallel is it's sort of exactly that when we draw the picture. We have another resistor up here, and these two sets of wires are parallel to each other. Okay? In series, you can go from one resistor to the other, all along the same path. There's really only one path here. In parallel, there are actually two paths. So there's a path here and a path there. Okay, so we still have plus here and minus here. Then we want to connect in parallel on the circuit board. So let's draw our picture here that's analogous to this one. Okay, so we're going to have several of these. And remember, these lines represent the rows of 5 holes. So I'm going to put one here and another one already there. So we have a resistor here. And then we have another one in parallel. So notice that the left sides of these two resistors are connected together and the right sides are connected. So in parallel, and this is really pretty easy here because you just draw them so that they look like they're parallel lines. So we have those two there. Now we need to connect to the power supply. So we're going to go from here over to our positive 15 volts, and we need to go, oops, not down there. As I said before, if your circuit doesn't work, make sure you've got things lined up like they're supposed to be. So then this one over to our ground, which is GND, so we go up to there. Okay, so that's what our circuit should look like. Now, we're going to do that. And we're going to use the same two, R1 and R2, that we did before. I have this one still in here, so I'm going to put my first resistor in there, and then just down here somewhere. And my second resistor, I'm going to put it beside that one, so I'll put it in here. And then I have to make sure that I get it in exactly the same row as the other two, or the other one. So these two are in the same row, these two are in the same row, and the same row as the power supply. Now I have this part, so I need to get my ground wire in the same row as the two ends of the resistor. So I have to take it out from where it was, and I'll put it up here. So I'll put it up there in that same row. And I just noticed I've left the power supply on while I'm doing this. That's usually okay. If you want to turn it off when you're changing the circuit, that's fine, but it usually is fine to just leave it on if you want to. Okay, so I have that in parallel, and I have not changed my voltage knob here, so it should still be 8 volts. And somewhere in here, okay, we're supposed to measure voltage. So I'll check the voltage and see if I still have 8 volts. So I'm going to put this up here and here, and I still have just a little bit more than 8, but that's about 8. Okay, and then if we check the voltage across each resistor, we can connect across one resistor, and then we move it over to the other resistor. And so we get the voltage across each resistor like that. Okay. Oh, now we get to, yes, another little more complicated part. It says label the points P1, P2, and P3 as described below. So the P1, now here it was pretty simple. Here's 1, 2, and 3. This one's a little more complicated. P1 is between the power supply and the R12 junction. Okay, here's the power supply. Here is the R12 junction. So we need between here. So I'll just put a dot here. This is P1. Now, P2 is between the R12 junction and R1. So here's the junction, here is R1. So I need my point P2 to be right in there. And then P3 is between the junction and R2. So here's the junction, here's R2. I'm going to put it up here. I could have put it over here, but I'm going to put it up here so it looks a lot like that one. So we're going to call that P3. Okay. Now we're going to measure those currents. And this is the part it's a little bit more complicated than this one. But let's see how that works. So we have our circuit still connected. We want our first one between the power supply and the junction. Okay. It might help to look at this. Here's the power supply and here's the junction. So what we can do is remove this wire, have it just sort of hanging out here in the air, and then measure the current from there to this junction here. So that's what I'm going to show you. I'm going to take this out, so we'll just sort of hold it up here in the air, and then make sure we're using the leads from our meter that we've been using for current. And I think I will try the red on the red here. And then I can connect to either of these two resistors because they're connected together. Okay, so I get a value, 0.546. Now, when you're doing this, you won't get this value. I want to emphasize you will not get this because I'm using different resistors on purpose so that you'll have to get your own values. Okay, so I removed this, inserted my meter, I have a number. Now, I would record that. And then I need to remove the meter and reconnect what I disconnected. Make sure you get it in the same row, okay? Because if you don't, then you didn't get the circuit back correctly. Okay, now P2 is between the junction and the resistor. Well, we don't want to snip that wire. And the wire is connected to the resistor, so we have to make our circuit break right over here. So what we can do is just pull this end of the resistor out of its socket there. So for our first resistor, over on the side next to the red wire, so here's the red wire, here's the first resistor, our R1. So we're going to just pull this out here, sort of leave it sticking up there in the air, and then we're going to connect, and I'm going to connect the red to this little piece of red that's down here. I think that should connect there. And then here is going to connect to the resistor. Okay, I get a number. I get 0.176. So of course your number will be different. But I write that down for the current for 0.2 because it's between the junction and R1. Okay, then I'm going to take out my meter and re-establish my circuit. You always have to put it back together before you make another measurement. So it's back like it was. Then I need to measure at point P3, which is between the junction and R2. So I find R2, which is this one, and I want to do it over here. You could put these points on the other side, but I think it's easier to leave them over here. So I want to pull this resistor out, not the whole thing, just the one wire. Have it sticking up here in the air, and then I'm going to connect the black to the resistor because it kind of goes to the black there, And then this red one, I can actually connect to the other resistor, or if I want to, I might go ahead and connect it to that red wire that I did before. And I get 0.373. So, of course, you'll get a different number. And then, if you were kind of noticing what these numbers are, there's a question when you do yours that will ask you, how are these currents related? And I think you can tell just by looking at the numbers when you actually do that. So then you need to take the ammeter out and then reconnect your circuit. So you always have to, when you break the circuit and make your measurement, then you need to reconnect your circuit. Okay, so then the next part is to add our 3 in parallel. So we have 2 of them in parallel. So 3, the third one in parallel, is going to be real easy. We'll just make sure it's in the same row of both of these, and we have a resistor here. So I will take my third one and have to find an empty spot. So I've used these 2. There's one in between, so I might do that. I could stick it in here, or I could actually put it on the other side of these 2 leads, which would be fine. But I'm going to put it in there. So then we have all 3 of them right side by side. So those are in parallel. And then there are some questions about measuring voltage and about measuring current. So since we've gone through the other part, you should be able to figure that one out. Okay, then the very last part is resistors in series and parallel. So it says to reposition R3 so that it's in series with the parallel combination of 1 and 2. So it's like, well, what does that mean? Okay, I'm going to erase, I think I will use a different color too. So what I'm going to do, R3 is this one that I put in over here. So I'm going to erase it. And then I need it in series with this parallel combination. So what I'm going to do, I think it's easier on the board. Now series, you could either put it above here or you could put it down here. I decided to put it down here. So these 2 are still in parallel. Then in series with that, I'm going to draw some more lines here and go down maybe to there. So here's my resistor R3. It was up here in parallel. It says to take it out and reposition it so that it's in series with the parallel combination of 1 and 2. And I think that is what it said. So now it's in series. So now then this, oops, not there. Beside that, because you can't put 2 wires in the same hole, so don't try that. So then this needs to go over here back to my ground wire. Now, it also says to draw the circuit. So I never drew my R3 up here. R3 in parallel would have been up there. So what I'm going to do is erase my P1, P2, and P3. I could have redrawn it over there, but I didn't want to get out of the range of the video. So we have the wires here like this. So this is R1 and R2. And then I want R3 in series with that combination. So what I'm going to do is I'm going to put it in the same position that this is. So it came from the positive part of the power supply to the parallel combination, and then go to the third resistor back to the ground. So the negative would be considered the ground. So our R3, actually let's do that with green. So our R3 is over here. Okay. So now this picture here matches this circuit. So we have our R3 in series with the R12 combination. Now, it tells you to measure the current. And we're relabeling, or we're changing our how we're calling the currents. Over here, we had current at 0.1, 0.2, 0.3, and the same sort of thing here. What we're going to do now is relabel the currents so that the current matches the resistor number. So we're going to have I1 is the current through R1, through T-H-R-O-U-G-H, R1. And I2 is going to be through R2, I3 is going to be through R3. And so if I get my color coding right here, this will be I2, and then I'll change this, and we have I3 will be through R3. Okay? So we're not telling you exactly which point to use, but if you want the current through R1, you should be able to figure out you need to break the circuit here, insert your ammeter, see what the current is, remove the ammeter, and then reestablish the circuit, and then do the same thing up here for R2, and then for R3, you can either remove the circuit here, you can pull this one out, or this one out, either one, and insert the current, the ammeter there to measure the current. A hint is if you get two currents to be exactly the same, then you haven't measured them correctly. I think on this circuit board it's a little bit easier to get the correct currents than when we've done it some other ways. But I can tell you ahead of time, if you get two exactly the same, something's not quite right. So if you have problems with this, you can always call me and I can help you figure out what you're not doing right. So after you have the currents, then there are some questions about writing voltage. I'm not going to say much about that now, but if you have problems with that, you can call me and we'll talk about it. So at the end, you're going to end up with two basic rules, Kirchhoff's rules. Some people call it Kirchhoff. I generally call it Kirchhoff. There are two rules for circuits, and you're not really going to do anything with them in this lab, but it was mostly to notice what they are, and then in one of the later labs, we will actually use those rules to solve some circuits. So, I think we have everything. Oh, you should always remember, turn the meters off, turn the power supply off, and if you're not coming back to it very soon, then you probably should unplug the circuit board. So.